In this lesson, we're going to look at solving quadratics using the square root method. So we have already looked at the graphing method and factoring method, so now we are going to discover what it means to be the square root method. So the first thing we need to talk about is what exactly is the square root. We have talked about this before, and if you will look in this first box, it says every positive number has two square roots, the principal square root and its opposite. So for example, the square root of 5 is the principal square root of 5, and negative 5 is its opposite. Now, you also need to remember that the square root of a perfect square is an integer. So let's look at that one first. So if you have the square root of 100, that actually has two square roots because it is a positive number. So what this means is that this can be a 10 times 10, which is positive 10, or this can also mean negative 10 times negative 10, which is still 10. So, but you look inside here and you will see that it's negative 10 squared, so the negative 10 comes out. Same thing over here, you've got 10 squared here, it'll be 10. So you have the principal square root, which is the positive 10, and you have its opposite of negative 10. Now, this is an example of where you can write your answers separate, or over here, you can use the plus minus symbol. So you could simply say plus minus 10 is the square root of 100. So, if we look at one that is not an integer, let's say square root 80, we cannot take square root 80 as easy as we could 100 because it's not a perfect square. However, we can break it down, and we kind of know that 16 is the square root of 4, and then the square root of 5 just stays 5. But now we have to remember it has a positive square root and a negative square root. So that's the first thing we have to remember, is that we are now going to list more than just the principal square root. We are also going to list its opposite. So that leads to the question of, if we're going to use the square root method, when would we use the square root method? So far we have only looked at standard form equations. And recall, this is standard form. The problem that we have in solving this is we have an x squared and an x. So we have factored. So we've already solved this with factoring. And we have also solved by graphing. But both options, even though they work sometimes, they're not always the best, because sometimes things will not factor, and sometimes if you do not have a graphing calculator, it's too hard to find the zeros. So this is when you use the square root method. It is actually when you do not have a bx term. So it is ax squared plus c equals 0. Now it is still a quadratic because you're dealing with an x squared, but since you only have the x squared, you can isolate the x squared to solve for x, and then you have to remember the x squared can have the positive or negative square root. So let me show you how this looks. So here is the first equation. X squared minus 16 equals 0. If you notice, this one here is missing the bx. Therefore, I can just isolate x squared with normal equation rules. So I have x squared. I'm going to take the 16 over. It turns to a positive. To get x by itself, I square root this side, I square root this side, and I get x equals a plus or minus positive 4. Now, we have already solved this one way. We actually have solved this with factoring, so I would like for you to make the connection here with factoring that this is difference of squares, and if I factor it using difference of squares, I get this factorization, and I get x equals a negative 4, and I get x equals a 4. So basically, when you're using the square root method, when you're factoring, it's difference of squares. But the good news is it doesn't have to be difference of squares for this method to work. Now, I want to kind of drive home the point that you will have two answers, and this is the reason. If we do a visual check, you can automatically see x equals plus or minus 4, factoring the zeros gave me -4 and 4, that this is a parabola with a -4, 0 and a +4, 0. And then you can automatically see that this is going to touch two times here. Now the vertex, we've been studying this, the B is 0, so if you plug 0 back in, your vertex is 0, 16. But I just want you to get a good visual picture of this. Why do we have a plus minus 4? It is because we have a parabola with an axis of 0, or axis of symmetry of 0, so it splits it right in the middle. So you have a -4 answer and you have a positive answer. So if you'll remember that, you will typically remember I have to put that plus minus symbol there. Okay, so now let's look at number 2. This one here is not going to be in standard form. It is 2x squared equals 8. Well, we don't really need to write it in standard form because we just need to get isolated the x squared. So I can divide each side by 2. I get x squared equals 4. Take the square root of each side, and I get x equals plus or minus 2. So once again, what this means for a visual check, we'll have a -2, 0, a +2, 0, and then if we were to factor it, if we were to write this in standard form, of course the 8 would come over. Once again, the axis of symmetry, because we do not have a B, would be 0. If we plugged 0 back in, we would get 0, 8 for the vertex, so we'll say that's down here. It is a parabola that opens up, so that would be the visual check again. So do not forget that you're going to have two answers. Okay, so now let's look at question number 3. This one looks a little different. This one is x squared plus 18 equals an 18. So if you look at that, you can automatically see, once again, I don't have a bx, so I can isolate the x squared. So I subtract the 18, and I get x squared equals 0. Take the square root of each side, so x equals 0. Now, what does this mean? Well, if we write it in standard form and I bring the 18 over this way, I am just going to get x squared, which is the parent graph. So why am I only getting one answer here? Well, visually, this is what it looks like. It is simply the parent graph. It looks like that. It's touching at the vertex, hence there's the answer. But I do not have two answers this time because x equals 0. It's simply sitting on the x-axis. So now look at what we have going on. We have examples with 2 solutions. We have an example with 1 solution. So you can probably guess what's going to happen with number 4. So let's go ahead and look at number 4. It is x squared plus 12 equals a 5. So once again, I do not have the bx in my equation, so I can isolate for x squared. I subtract 12. I get x squared equals a -7. And there is a problem. We cannot ever have two numbers multiplying together to give us a negative. And you all know from the previous chapter, when I go to solve x, I am not allowed to have a negative underneath the square root. So x equals nothing. So this is a no solution one. But what does that mean visually? Well, if I were to go ahead and write this in standard form and bring that 12 over, I would have x squared minus, or actually plus the 7, because I would this time add the 5 over here, or subtract the 5 over here, equals 0. So what that means is the axis of symmetry is still at 0, so it's still x equals 0, and now the vertex would be at 7, so 0, 7. So it is going to be a parabola opening up way up above the x-axis. Therefore, that is why you do not have any solutions. So here are the options that can happen solving quadratics with square roots. You can have 2 answers, you can have 1 answer, or you can have no answers if that number is a negative. You will not have any zeros. So let's go ahead, move down to box 5, and let's try this problem here. 3x squared minus 11 equals 7. So we are going to try to isolate the x squared. Good news, we can. The bx term is missing. Therefore, I just add 11 to the other side, and I get 3x squared equals 18. I divide by 3 to isolate the x squared. I get x squared equals 6. And now, depending on the directions, you can go 2 different ways. You can go ahead, take the square root of each side, and you can say x equals a plus or minus square root 6. Now that is what we call an exact answer. But if it tells you in the directions to round your answer, you would say x equals plus or minus, and you would take your calculator and you would follow the directions. If it is square root 6, and if it told us, let's say, to round to the nearest hundredth, we would simply say x equals 2.45 if it told us to round. Now, why is it better to use an exact answer? Well, because we can check these. If I check using a decimal, it's going to be off a little bit. But if I check this using the square root, it's going to be an exact answer. So let me demonstrate that for you. We have 3 times the square root of 6 squared, and you know what's going to happen there. That square is going to undo that. Subtract 11, I automatically get 7. If I do not use the square root 6, and I use the 2.45, I get 7.0075, so that's a little bit off because I rounded that answer. Okay, so sometimes it is better to use an exact answer. Okay, so now let's go to number 6. And for number 6, let's do this one. Negative 16x squared plus 9 equals 0. So if you would pause the video and work that one out. Okay, I have it worked out here, and I want you to notice that I kept everything exact. I subtracted the 9. I divided by the 16. 2 negatives make a positive, so I square rooted both sides. I did not convert to decimals. I used my radical rules. Square root 9 over the square root of 16 is a plus or minus 3/4. Now, I want you to draw your attention to this problem right here because you've actually seen this problem before. This problem here was on your study guide about the squirrel dropping the acorn. And I told you to do this with difference of squares on your study guide. But if you notice 3/4 seconds, that's the same answer. So here is an example of how it's actually a little bit easier to do the square root method. Okay, so now stop this video and flip your notes over for the next video.